Okay guys, welcome to this A2 level pure mathematics video, okay, looking at differentiation involving the quotient rule. So this is aimed at predominantly year 13 level students, okay, in the UK, so in England, okay, but it's also appropriate, yeah, as well actually, yeah, for year 12s as well, okay, if you're learning, yeah, differentiation involving the quotient rule. Okay, so this is question number one, guys. I've got y is equal to e to the 2x all over x squared plus 2. Find dy by dx. Okay, so first of all, yeah, label the numerator as u. So u is equal to e to the 2x. And v is our denominator, which is going to be x squared plus 2. Okay, now differentiating, okay, each function separately, okay, du by dx, so du should be a u there, yeah, just to make it clear, not a v, sorry, it's a u, so du by dx, well, the 2 comes down here as a multiplier, so yeah, it goes to 2e to the 2x, okay, so differentiating 2x, and it comes down, yeah, as a multiplier. So differentiating here, 2x is just 2, so that comes down here as a multiplier, okay, for that, okay, dv by dx, so differentiating x squared, the power comes down, okay, as a multiplier, and then the power comes down by 1, so 2 goes here, so 2 goes here, and then the power reduces by 1 here, which is just x to the 1, which is just x, okay, and then differentiating the number 2, a constant, just goes to 0, okay. So yeah, plus 2 goes to 0, okay, when you differentiate it. Okay, so the formula for dy by dx, okay, of u over v, okay, so when you have a fraction here, that's what I call a quotient. A quotient here means that I've got a fraction here, like a division. Okay, so u over v, it looks like a v there, guys, I apologize. Sorry, yeah, about the actual lack of spacing here. So the formula is as follows. It's v du dx. Okay, so order here, yeah, actually matters. So v du dx subtract u dv dx all over v squared. Okay, now I do believe actually, unless I'm mistaken here, I do believe actually they obviously give you this here in the actual formula booklet. Okay, but if they don't, then obviously, yeah, please do obviously actually learn it here. But as far as I'm aware, from memory, this is given here as part of, yeah, like the formulas, yeah, for differentiation, okay, within, yeah, the functions, okay, yeah, so it's v du dx subtract u dv dx all over v squared. Okay, so using this formula here, so dy by dx, okay, so taking our time here, so being very careful, okay, and again, sorry, yeah, about like switching my work here, so v du dx should be 2e to the 2x, okay, and then in brackets x squared plus 2. Okay, let's just obviously delete that here. So let's delete that in little lines. Okay, for that. Subtract u dv dx. So that times that. So subtract 2x e to the 2x. Okay, all over v squared. So all divided by x squared plus 2 all squared. Okay. Now I can leave it like that, okay, that would obviously suffice, but yeah, I'll just obviously tidy up the actual numerator here, but I'm not gonna bother ever like explaining the actual denominator here, because then it becomes a bit messy, okay, but you can, yeah, obviously expand and simplify here, top and bottom if you want to, but I discourage you obviously here, because in your exam here, you are on like a time limit, like even if it's like a 2 hour paper actually, obviously, yeah, it still obviously takes a bit of time to obviously expand and simplify all that, okay, but where possible, simplify, yeah, the numerator, but leave, yeah, the denominator, yeah, actually factorized, okay, yeah, or within its power. Okay, so expanding the top actually, I'm going to get as follows. So expand this, yeah, so I'll get 2x squared e to the 2x, so I'll get 2x squared, so 2x squared, okay, e to the 2x, okay, so that's, yeah, sorry, I should delete that actually there, and then I'm going to have plus, and then I'm going to have, I think, 4 lots of, so 4 lots of e to the 2x, yeah, when I expand that single bracket here, sorry that I actually deleted there, but hopefully you can remember that, okay, yeah, okay, it's v du dx here, so it's this times this plus this, yeah, the same number times 2, okay, now I can factorize the top, okay, so I can take out 2e to the 2x as like a common factor, okay, And this other bracket, I'm going to have x squared plus 2 subtract x, okay, for that, okay, all over x squared plus 2 all squared, okay. And that, yeah, is as far as it goes here when you obviously simplify it. Okay, I can obviously factorize this here, but I'm not actually going to bother. But yeah, that is, yeah, like obviously simplifying, yeah, obviously a bit further. Okay, that's important because a part B might say that, yeah, like find like a stationary point, okay, yeah, or like a turning point, yeah. So that's when you set the derivative equal to 0. Okay, so yeah, you will have like a quadratic there. So you have x squared, yeah, minus x plus 2, which I don't think actually factorizes this year, but yeah, essentially you may or may not have your like turning points here depending on the question. Okay, but yeah, sorry for taking a while actually on that. Okay, second question, y is equal to sine 2x all over x plus 3. Again, label, okay, so find dy by dx. So y is equal to sine 2x, okay, and v is equal to x plus 3 all to the power of a half here. So square root means power of a half. So x plus 3 to the power of a half. Okay, sorry, it should be u is equal to that, not y, sorry. So u is equal to sine 2x. Okay, so u is always equal to your numerator of your fraction, and v is always equal to your denominator to make it a bit easier. Sorry, I'll put dy by dx there again. So du by dx. So differentiating sine 2x using, yeah, the chain rule. So differentiate 2x goes to 2, so that comes out as a multiplier. Sine goes to cos, so yeah, it's just 2 lots of cos 2x. And again, yeah, they are ones, yeah, that you'll have to remember, yeah, for your exam. Okay, yeah, so make sure that you practice, yeah, differentiation, yeah, of your trig functions. Okay, again, yeah, I'm treating this here like a revision video here, so bear with me, guys. Yeah, okay. So a revision video, yeah, assumes that, yeah, a lot of this here you obviously covered it here, but again, yeah, feel free to obviously pause here and obviously go back where possible. dv by dx, so the half comes down as a multiplier, okay, half brackets x plus 3, okay, to the power of minus a half, okay, yeah, because the power comes down by 1, okay, and the power reduces by 1, okay, times the derivative of this, which is going to be 1, okay, so yeah, it doesn't actually change my answer. Okay, so dy by dx, okay, yeah, so this one here is a bit more fiddlier, a bit more trickier. Okay, so it's v du dx, so yeah, it's going to be 2 cos 2x, and then yeah, I'll put like a little bracket, and then it's going to be x plus 3 to the power of a half. Again, I might not have much space here, I apologize. I'll try and put like a little square there, yeah, not actually box it off. Subtract u dv dx, so that times that, so I'm going to have, yeah, a half sine 2x, and then open brackets, x plus 3 to the power of minus a half. Okay, all divided by, yeah, v squared. So if you square that, yeah, you would just get x plus 3 on the bottom. Okay, now I can actually simplify that actually, but I'm not going to bother here because of like lack of spacing here. But I can factor out here an x plus 3 to the minus half on the top. Okay, yeah, and simplify where possible. Okay, yeah, for that one. Okay, but sorry, yeah, in this video because of, yeah, like lack of space actually here, then I'm not gonna actually bother here. But you can obviously simplify the top there if you want to. Okay, the bottom, yeah, because if you remember, yeah, so if you square obviously v, okay, the square root, yeah, and the square obviously they cancel out, yeah, so hence why I'm just left with x plus 3 on the bottom, yeah, obviously it's the power of 1, yeah, all of it to the power of 1. Okay, yeah, but I don't need to bother, yeah, with that power of 1 there. Okay, so that's my answer for that one. Okay, this next one, okay, so y is equal to natural log 2x, okay, or ln 2x, or ln 2x, all over x squared minus 4. Find dy by dx. So again, u is equal to natural log of 2x, okay. V is equal to x squared minus 4. Okay, sorry about my handwriting, guys. Hopefully you can forgive me. Okay. So du by dx, so differentiating, yeah, natural log x, okay, goes to here just 1 over x. Okay, when you simplify that, okay, because it goes to here, so it goes to 2 over 2x, which simplifies here to just 1 over x. Okay, yeah, for that. Okay, so a little rule there. If you ever have your natural log of like ax, and you differentiate that, yeah. So if you find the derivative of that, so d by dx, yeah, of natural log of all that, yeah, it's just going to be a over, yeah. So it's a over ax, which just simplifies, yeah, to just 1 over x, yeah, if you're interested, okay. That is meant to be an a there, sorry. Okay. And then differentiating v, so dv by dx, x squared just differentiates to just 2x. Okay, now putting this all together, so dy by dx, guys, yeah, again, I'll try and do it to the left a bit more. So dy by dx, again, sorry if actually squishing a lot of my work here, I do apologize. Okay, so it's v du dx, yep, so it's going to be this times this, which goes to just x minus, yeah, 4 over x, yeah, or 4x to minus 1, yeah, I'll write it as, okay, and then subtract v du dx, sorry, u dv dx, so yeah, it'll be 2x natural log 2x, and then all over v squared, so all over x squared minus 4 all squared. Okay, I'll just move that there, sorry Nick, just delete that little fraction, we've got a bit more space. Okay, so x squared minus 4, yeah, all squared. Actually, sorry if I'm actually squishing it there. Okay, and that would be your final answer. Of course, I can factorize here an x out on the top. Okay, to simplify that any further. Okay, yeah, so I'll do that actually now. Actually, so I'll just obviously delete this. Okay, part. So for this one, yeah, if you factorize the numerator, okay, you get x brackets 1 minus 4x to the minus 2. And then minus 2 natural log, yeah, of 2x. Okay, and then close your brackets, all over x squared minus 4 all squared. Okay, and again, in the exam, guys, yeah, I would have encouraged that. Obviously, in this video, yeah, obviously, like, I've summarized, yeah, and because of lack of spacing, okay, but in the second one, yeah, you are able to obviously factorize that here. So the second one, you are able to take out x plus 3 all to the minus half out as a factor, okay, and simplify that further. Okay, and the reason for that is because a part B or a part C may say to you, yeah, work out the stationary points here, or find the coordinates here of your stationary points or your turning points. Okay, okay, yeah, for that one. Okay, yeah, so remember that when you set dy by dx equal to 0, okay, that's where you find your stationary points. Okay, yeah, so your turning points or your stationary points. Okay, turning points here is what we say are more GCSE maths. Okay, yeah, but stationary points here is what we say at like A level maths. Okay, so hopefully it made sense, guys. Okay, yeah, sorry for actually rushing it. Yeah, at the end actually, and sorry actually for any, you know, like bad handwriting there, but hopefully you can follow me. Okay, yeah, just to make clear here, so what I'll do is I'll just delete actually this last part, and I'll just factorize the numerator here, just so you're happy with, yeah, what this actually factorizes to, yeah, because, yeah, it's a minus half there actually, by the way. So on the numerator for this one, it would go to x plus 3, okay, to the minus a half, okay, and then, yeah, open bracket, so open a big bracket, I'll put it in square brackets. I'm going to have 2 cos 2x, and then that is going to be times by, yeah, just x plus 3. The reason for that is because the rules of indices state that, yeah, if it's power of 1 there, minus a half plus 1 gets me to a half. Okay, yeah, so yeah, that is how I got that part there. I'm sorry about that. Okay, and then it'll be minus, yeah, 1/2 sine 2x. Okay, and then close your, like, yeah, it's just square brackets. Okay, obviously that would all be over, yeah, to make it clear, that would all be over x plus 3. Okay, okay? And then what I can do here to obviously make it a bit more tidier is just bring this down with this one, okay, because the minus obviously flips it. So yeah, what I'll get is I'll get x plus 3 to the power of 3 halves on the bottom, okay, and then my numerator just becomes, yeah, sorry for like finishing it, but so numerator literally just becomes 2 cos 2x, x plus 3, okay, yeah, so it literally just becomes 2 cos 2x brackets x plus 3 minus a half sine 2x, okay, because I've dealt with, yeah, that the other part, yeah, by obviously flipping it, okay, because remember the minus power does the reciprocal, and I've just added it, yeah, so I've added the power there here, so obviously it was a power of 1 there, and then I added a power of a half using the rules, yeah, and the laws of indices. A half plus 1, yeah, is 1.5 or 1.5 or 3 halves, okay, but at A-level maths, yeah, I try and leave my answer or answers, yeah, as improper fractions, yeah, or like top heavy fractions, yeah, where possible, okay, so I try and leave it in like exact form, yeah, and like avoid, yeah, having it as like a decimal, okay. Right, guys, yeah, so sorry actually for like rushing that last part actually, but hopefully it made sense. Okay, any questions, any queries, put it in the comment section. Thanks for watching. Okay, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside the next video. Okay, so thank you for watching this A-level maths video. Okay, bye for now, take care, all the best, guys.